Okay, so this video we're going to take a look at number 1 and number 5 from the test review. So we've got 396 a to the 14th, b to the 5th, c. We need to simplify this radical. So we essentially need to kind of treat each one of these components separate from each other. So first we do 396. It does turn out that 4 goes into that. It goes into it 99 times, which means 9 also goes into it. So 36 goes into 396. If you divide that out, you get 11. And so the square root of 36 is 6, and then you've got an 11 left over inside the square root because 36 times 11 is 396. And then you remember we have to divide the exponents by 2 to do the square root of it. And so a to the 14th by 2 is a to the 7th. None left over because there's no remainder. B to the 5th divided by 2 is 2. 1 remainder, and so the b there. And then the c, since it's an exponent of 1, divided by 2 has 0, so we don't put a c out front, but a c does remain inside. And so that is the square root of it, but we did say you have to consider absolute value, which means it's possible for a or b to be negative or c. At the beginning of the problem, neither b nor c can be negative because that would give us a negative result inside the square root. And so that doesn't work because that would be imaginary and we're assuming everything is real. But a could be negative. And so if a was negative, a to the 7th, once you did the square root, would also be negative. But we know that we're talking about the principal square root. So our resulting answer has to be positive. So the a to the 7th needs a square absolute value around it. Remember, if it's an even power inside the square root and an odd power outside the square root, that's when you need absolute value. All right, for number 5, you've got the square root of 15x to the 7th y all over 6x squared y to the 4th. Okay, so there's a couple things that need to be done on this one, and this one's a little bit tricky. The first thing you should always do on a problem like this is simplify inside the square root to begin. 15 over 6 simplifies to 5 over 2. 7 is greater than 2, and so we're going to subtract our exponents and get x to the 5th. 4 is greater than 1, it's like y to the 1st, and so we subtract the exponents to get y to the 3rd in the denominator. Okay, and so at this point, what I'm going to go ahead and do is rationalize the denominator first. And so the way to think about this is remembering that the square root of the fraction is the same as the square root of the numerator over square root of the denominator. And so we know it looks like this. And we don't want a square root in our denominator. So we need to make both parts of that perfect squares. And to do that, we need to multiply by square root of 2, because square root of 2 times square root of 2 is 2. And then the y to the 3rd is not a perfect square, so we need to multiply by a y to make it y to the 4th, which would be a perfect square. And then whatever we multiply the denominator by, we have to multiply the numerator by. And so that gives us the square root of 10 x to the 5th y all over, well, that's going to give you 4y to the 4th. Well, the denominator simplifies to 2y squared. That was the whole point of this, was getting rid of the square root in the denominator. And then the numerator, 10 doesn't have any perfect squares that go into it. We can divide 5 by 2 to get x squared, which leaves us 1x left over. And then y is just going to be left over as well. And so that's why you get x squared times the square root of 10xy all over 2y squared as your answer.